Look at this wide expanse. Before 2004, much of Dubai was a quiet, flat stretch of sand, entirely missing the dense maze of skyscrapers and flashing lights we know today. But city planners had a singular idea to draw global attention. They wanted to build upward, literally trying to touch the sky, and they set a staggering target. This structure would reach 828 meters into the air and stack 163 usable floors on top of one another. Achieving this height required engineering capable of withstanding an environment that was actively working against it. You can see the first major hurdle right here in the excavation site. Workers weren't digging into solid bedrock. They were trying to anchor thousands of tons of steel into shifting, unstable sand. Then came the heat. Crews had to perform grueling manual labor while temperatures regularly spiked to a blistering 50 degrees Celsius or 122 degrees Fahrenheit. And waiting for them higher up was an even bigger threat: severe, high-altitude winds, strong enough to topple a traditional skyscraper of this size. At these heights and temperatures, the physics governing a standard skyscraper no longer apply. To build safely in these conditions, engineers moved away from traditional high-rise blueprints to develop a custom structural system. Take a look at this spider lily. The solution to those punishing high-altitude winds came directly from the geometry of this local desert plant. This aerial view reveals how engineers translated the flower's radial petals into a massive, three-pronged Y-shaped foundation. Instead of blocking severe winds, its staggered outer edges slice right through them. That central nexus guarantees 360-degree stability, preventing the tower from twisting. By mimicking the desert flora, engineers took a destructive force of nature and seamlessly deflected it around their work. But standing firm against the wind was only half the battle. They had to transport thousands of tons of liquid concrete straight into the sky, and the extreme heat created a ticking clock. If the concrete moved too slowly, it would solidify inside the pipes before it ever reached the top. This cutaway shows the solution. They designed a custom pumping system capable of generating massive upward pressure, forcing the liquid concrete hundreds of meters vertically in a matter of minutes, setting a new world record. Here you can see the mid-climb progress. Thousands of workers labored day and night, incrementally pushing this structure higher through the scorching air. Inside that shell, they were building a massive vertical city, complete with luxury hotels, spacious corporate suites, and high-end apartments. To make an ecosystem of that size function, they installed some of the world's fastest elevators, rocketing passengers upward in a matter of seconds. It operates as a completely self-contained vertical world, relying on record-breaking technology to conquer extreme distances. When you finally reach the absolute peak of this silhouette, you encounter a physical anomaly known as the double sunset. Here is how it works. You can stand on the ground floor and watch the sun dip completely out of sight. Then, if you immediately step into one of those ultra-fast elevators and ride it to the observation deck, you travel high enough, fast enough, to watch that exact same sun set over the horizon a second time, while the city below you is already in darkness. By traveling that fast vertically, the structure actually warps our normal experience of time and celestial events. In January 2010, the project was complete, and Dubai officially claimed the record for the tallest structure ever built. Looking straight up this gleaming facade, you can see how it completely dominates the modern skyline. The finished tower utilizes nearly 500,000 tons of concrete and steel, reaching a height twice that of the Empire State Building. It accomplished exactly what its planners set out to do, taking a quiet desert and turning it into a global hub that commands international attention. This project demonstrates that extreme engineering can redefine a city's landscape, proving that even a barren desert can sustain the world's tallest peak. Subscribe for more stories on the structures that defy expectations.